Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to everyone. Okay, so today the next problem solving we need to try to solve is related to the simple harmonic motion. Okay, for example, given a question, a spring stretch 0.5 meter when a 0.3 kilogram mass is gently lowered on it. So the spring is then set up horizontally with the same mass 0.3 kilogram resting on the frictionless table. So the mass is pulled so that the spring is stretched 0.1 meter from the equilibrium point and released from rest. So determine first the spring stiffness constant, or the value of K. So the amplitude of the horizontal oscillation A. So the next, the magnitude of the maximum velocity, and the last question asks to find the magnitude of the velocity when the mass is 0.05 meter from equilibrium. Okay, first to solve this kind of problem, okay, we need to understand this, the diagram of the simple harmonic motion for this one. If you can see here, they have two conditions. First, the spring stretch 0.15 when a 0.3 kilogram is gently lowered on it. So in this case, the first case is the vertical spring. Okay, for a vertical spring, okay, you need to know, for example, we have a vertical spring. Okay, here the vertical spring at rest without attach any object. So at this point, so the line there, so when the spring is attached to a 0.3 kilogram mass, so for example we have, so when I attach to a 0.3 mass, so the mass here is 0.3 kilogram. So at this point, so the spring stretch is 0.15. So the value 0.15 is here, 0.15 meter. So for a vertical spring condition, so this is the considered as the equilibrium position, or x equals to 1. Okay, this is the for a spring attached in a vertically condition. Okay, next, the spring is then set up horizontally with the same mass resting on the frictionless table. Okay, this is the first condition you need to know. So the second one is the spring, okay, attached to the same mass m 0.3 kilogram, okay, on a frictionless table. Okay, assume the table is frictionless. Okay, and the mass is pulled so that the spring is stretched 0.1. So in this case, the mass is pulled, so here the new distance of the object, so the distance here is a 0, x equals to 0.1. Okay, so question asks to determine the spring stiffness constant. Okay, to find the spring stiffness constant, we know the equation from the Hooke's law. We have the equation F equals to negative kx. Okay, please take note, for any calculation in a simple harmonic motion, the negative sign we need to ignore. Do not substitute into the value. The negative sign just indicate that the force is the direction of force is oppositely direction to the displacement. Okay, from here we have the value of, we have the value of mass and x. So for a vertically attached object, so we know we have the weight downwards. So in this case, weight equals to mg, or also equals to force. So in this case, to solve problem A or question A, so we know that F equals to mg, so equals to kx. So to find K, spring constant, so we have K equals to mg over x. Okay, so from here we can find value of K, whereas the mass given is K equals to 0.3 and the gravity value is constant 9.1 over x is this distance 0.15. So from here we calculate the answer. You will get the value of K, or the spring constant, is 19.62 Newton per meter. Okay, so we solve the first question. Okay, next the question asks to find the amplitude of the horizontal oscillation. So to solve this problem B, so consider the horizontal case. So refer to this diagram. Okay, please always remember that for a spring, when it's stretched or compressed, the maximum distance from the equilibrium position we consider as the amplitude. So in this case, the x equals to 0.1 also equals to the amplitude, which is the value of A. So for the question B, the amplitude of the horizontal, so we can directly answer amplitude equals to 0.1 meter. Okay, so we get the answer for B. Okay, next we proceed to the question C. So the magnitude of the maximum velocity, we symbol it by the V maximum. Okay, to find the V maximum for a simple harmonic motion, we have the equation V maximum equals to A omega. If you notice in this problem, we have the value of A, but we don't have the value of omega. Then what is the relationship between omega and the other value that we have here? So the other formula you can use is omega equals to square root K over M. So from here, to find the V maximum, we can substitute omega into here. This omega, substitute here. So to find V maximum, so we have A times square root K over M. The value of K we have, and also the mass of the object we have. So the amplitude in this case is 0.1 K. K spring constant, M is a mass, so times square root K is 19.62 over mass is 0.3. So 0.3, so you calculate, you will get the answer is 0.809 meter per second for V maximum. Okay, and then the last question asks to find the magnitude of the velocity when the mass is 0.05 meter from equilibrium. So in this case, or this condition, the question asks to find the mass. So the question asks to find the velocity when the mass is 0.5. So if we refer to this diagram, it means that when the mass is 0.05 from equilibrium, is around here at this position. So when the mass is here, what is the V? Okay, so to solve this problem, so we have the formula V for D. Okay, we have the formula V equals to omega square root A squared minus X squared. Okay, so the magnetic velocity when the mass is 0.05, okay, at this point. So to find the velocity, okay, omega, we know the equation omega is square root K over M. So we have here square root K over M, okay, times, okay, square root A amplitude is 0.1 squared. Okay, so X is referred to this condition when the mass at 0.05. So for x here is 0.05. Okay, squared. So this one square root. Okay, so from here you substitute value of k, which is spring constant. Okay, square root 19.62. Okay, and the mass 0.3. So you substitute this one. Okay, and then you will get the answer is 0.05 squared. So the final answer you will get is 0.70 meter per second. Sorry, meter per second, yes. So finally we get the answer for the velocity of the mass when it is 0.05 meter from equilibrium. Okay, that's all. You can try by your own side. Okay, good luck.